I'm Dr. Stauber. I teach math and physics here at Elkins College, and this is our makerspace. So laser cutter in the corner. We've got two different types of 3D printers. This is your typical extrusion printer, and this is our resin printer. And this is new for us, a printed circuit board etch mill. And here in the corner we have an ESD soldering station. So let me show you some of the cool things that you can make with these things. Starting off, we have a little RFID scanner here. You just scan your access card, and this unlocks this little latch here to give you access to the space. And perhaps you're thinking, wow, that is really cool. How do I get access to the makerspace? Well, I'll tell you. You take a little online certification class. It takes about 20 minutes, and then you get some familiarization training, either with me or some of the student leaders like Matthew Weintraub, and we'll give you one of these little fobs, which can give you 24/7 access to the makerspace. So here's some of the things that students have made. Starting out with the laser cutter, you notice that they're used for electronics enclosure boxes, but that's not all, right? Some students printed out little business cards. I mean, how much cooler is it to give somebody a business card that's been etched with a laser cutter instead of just a boring little cardboard stock business card? And then pretty much anything that you can capture electronically, you can reproduce with the laser cutter. So here's some capstone projects that were left behind. Here's a automatic fish feeder that gets glued to the side of the aquarium. This one's an automatic plant watering device that automatically monitors the moisture level in the soil and then turns on this pump when the moisture is low. And then we're making some plaques for different organizations on campus. And this is not quite done yet, but we plan to etch a lacrosse ball and a pledge paddle. So, some ideas hopefully to get you started on laser cutter projects. Also, wanted you to see that we have a computer controlled embroidery machine, and Wendy Morgan's doing a separate video on this, but here's some projects that students have done. Again, any image that you can digitize, you can stitch out with the machine. Some students made a pillowcase with a little embroidery on it, and a student with nursing background is making a Teflon covered canvas sled to make it easier to move patients around on a hospital bed. And here's some things that have been made with the 3D printer. So I mentioned that we have two different kinds of 3D printers. One is the sort of classical extrusion 3D printer, which you can use to make boxes like this. Here's a little ring box that somebody made, and a castle and things like that. These were all done with the extrusion printer. So is T-Rex. But our resin printer is capable of really fine detailed prints. I don't know if you can kind of see that, but I mean, that's something that would be very difficult to do with the extrusion printer, or little figurines like that. And last year, or the year before, we had a team from Elkins College go to Oklahoma to compete in an international robotics competition. And every bit of this, except for this little bit of 2x4, was printed out with the 3D printer. And they won Judge's Choice because there's nothing here that's commercial off the shelf. Everything is homemade. And the idea was we wanted to navigate an obstacle course in Oklahoma while controlling it here from D&E. And the brain of the device is this postcard-sized microcontroller called an ESP8266. And I'll show you some more of those in a second. So here's our laser. I would say this is the thing that gets the most use. And our extrusion printer. So this is the one that just extrudes plastic from this tip and builds up your print one layer at a time. And then this is our SLA printer. And the idea here, it's a little bit like Terminator 3. This foot goes down in this bath full of liquid resin, and there's an LED screen that illuminates one layer at a time, and as your print is developed, it pulls it out of the bath. And this is our new edition, printed circuit board etch mill. And it gives us a capability that no schools in the area have. In fact, not even the Tier 1 school in Morgantown can do this right now. So we can make double-sided printed circuit boards The idea is you take a copper-clad board like this, it's a copper-clad fiberglass board, and you can etch out you design your circuit in a free program like Eagle, and then you can etch out the top and the bottom, and then route out the outside edge. This is the way we used to do it. If you just put a mask on top of a piece of copper and then you dip it in ferric chloride, eventually you'll get something like this. It's not nearly as clean or neat, and you're not able to do two-sided boards with this. The idea is, once you create a printed circuit board, you populate it with electronic components. You solder it at our ESD soldering station, and then you can't just deliver this to a customer like this. You're going to want to put it into some kind of enclosure, which is where you would use your 3D printer or your laser cutter to make a box for it, hopefully some artistically rendered box. And finally, we have a student that's working on a forge. So just melting down aluminum to recast. I really think that between these additive manufacturing items and the Arduinos, actually let me just show you this box of Arduinos. There's all the boxes on the edge there are just filled with resistors, transistors, capacitors, inductors, sensors for the Arduino. This is the ESP8266 that I talked about. It's like the Arduino in that the Arduino is a microcontroller that has some general purpose input-output pins on it, some A to D converters. So it allows you to, if you know how to program it, it can interact with its environment, can make decisions, it can do your homework. For example, you can awesomize your house by having an RFID reader button on your shoe, and as you walk over the welcome mat, it'll start your coffee machine or read you the news or something. And these ESP8266s are like it in the sense that they are very much like Arduinos with general purpose input-output ports, but they also have a Wi-Fi antenna on them. So this is how we were able to communicate with the robot in Oklahoma from D&E, and it's the enabler for a lot of Internet of Things. So that completes the tour of the makerspace. The bottom line is, this is your space. Please come and take advantage of it. The only limit is your imagination. I think with all of this technology and some of the capabilities of the tech shop, which is kind of your more traditional machine shop, and Arduino and LilyPad and so on, if you have an idea, we can manifest it. Thank you.